All right, students, 2.68x squared plus bx plus c is greater than 1. I'm sorry, a is greater than 1. So our essential question is, how can we factor ax squared plus bx plus c when a is greater than 1? And so the first thing we want to think about is anytime you see a greater than 1, the first thing you want to see is, can I factor out a GCF? Okay. If I cannot factor out a GCF, then we'll go straight to the big X. But if you take a look at A, GCF, remember, is greatest common factor. If you take a look at A, again, I trust that you guys have paused the video and you wrote out your outline, and we're going to go ahead and get started. So the first thing we want to do is factor out that A. What that means is, what number can divide, if you look at 5, 15, and 10, what number can you divide out? And it is 5. So when we factor it out, what's left on the inside is x squared plus 3x plus 2. Now, if you want to check my work, go ahead and check it. 5 times 1x squared is 5x squared, which is here. 5 times 3x is 15x, and 5 times 2 is 10. So when you factor out a number, just go ahead and simply double check, multiply, and make sure you get the correct number. Okay. The next thing I want to focus our attention on is just whatever's inside the parentheses. Don't worry about this 5 on the outside. We factor that out. That's just going to be part of our answer when we're factoring. So just this, I want to create the big X, just using whatever's inside the parentheses. Again, we're going to take our A. A is 1. A times C is 1 times 2, which is 2. It's going to go on top. Our 3, which is our B value, that's going to make up the number at the bottom. Just like what we did in 2.5, we want to make sure that our two numbers, when we multiply them, we end up with 2. At the same time, you add those two numbers, you make up 3. So the only numbers that make up 2 is 2 and 1. And at the same time, if I were to add 2 plus 1, that would give me 3. So I know it's 2 and 1. Okay. Now, remember I said bring down that 5. Got to bring down that 5. X plus 2 and x plus 1. Now, super important, this happens all the time, no matter if you're a Math 2 or Math 3 student. When it says to factor, students, we stop right here. If it asks you to solve, then you would set it equal to 0, or they would give you the equation which is set equal to 0. So because it's saying, hey, just factor, we're going to stop right here. Okay, we were able to factor out a GCF. We're also able to use the big X and create an expression. Okay, again, we're still factoring, we're not solving. And so our goal is to see if we can factor out a GCF. So what number can I factor out? And GCF is your greatest common factor. So I know we can factor out a 2, but there's a number that's even larger than that. And you have to be able to find those numbers. It's actually 4. It's not always going to be the leading coefficient, but these just happen to be the leading coefficient. Okay. All right. So let's go ahead and factor out the 4. And then we're going to write out our trinomial. What's left on the inside of the parentheses? We have x squared. And we have a plus 8x, and we have plus 15. Okay, double check my work. 4 times x is 4x squared. 4 times 8x is 32x. 4 times 15, that gives me 60. Again, we are only factoring here. So I'm going to highlight what I'm going to use the big X on. I'm looking at what's inside the parentheses. A is 1, B is 8, C is 15. To get this top number, A times C, which is 1 times 15, that's 15. Our B value is 8, so that number is going to go on bottom. What two numbers make up 15? 1 and 15, 5 and 3. So it looks like 5 and 3 are going to be our answers. Okay, we're going to take that. Remember, bring down that 4. If you don't have the 4 as part of your answer, it's incorrect. Okay, and we have x plus 5 and x plus 3. Again, we are simply factoring. There's your answer. Please organize your notes. All right. Now, sometimes, if we can, always factor out a GCF. Okay, that's the first thing that you want to look at. Can I factor out a GCF? Well, I know 2 can go into 2. 2 cannot go into 7, but 2 can go into 6. Unfortunately, we cannot factor out a GCF. So what we're going to do is I'm going to show you how to use the big X here. Because A is greater than 1, it's a bit tricky. There's an extra step that we're going to have to take. Okay? The big X is still the same. I'm going to take my highlighter and I'm going to highlight this 2. This 2 is going to play a huge role in several things. And I'm going to draw my big X. Remember, we are used to multiplying A times C. And that's not going to change, students. Our A is 2, our C is 6. So it's now 12. Our B is not going to change. Our B is 7. So that's going to stay the same. But I've underlined this, our A value. Because it is greater than 1, we are actually going to use it to create our expression down here. So we're going to use it to create our expression. Okay? This is something that students commonly miss on homework assignments. I'm sorry, not necessarily homework assignments because they get used to it, but when they're taking the quiz, they kind of want to go back to 2.5, and they forget that because A is greater than 1, they forget to bring that 2 down, okay, or whatever the coefficient is, 3, okay. So, what 2 numbers make up 12 at the same time add up to 7? It is 4 and 3. 4 times 3 is 12. 4 plus 3 is 7. So let's go ahead and put plus 4 and plus 3. Okay, I'm going to tell you right now, when you have a leading coefficient greater than 1, which we do have here, you have to divide one expression, if not one, both expressions out by a number. Okay, so what does that mean? That means that we're going to have to simplify, okay? In this case, it looks like the first expression, we can actually divide each term by 2. And that gives me x plus 2. Notice how we have a 2 and 3. It's not going to divide out evenly, so I'm just going to bring that down. And there's my answer, students. That's my final answer. Now, if you don't believe me, you're like, I don't know, Mrs. Holmes, how do I know? Because if I multiply these, we know how to multiply binomials. You can use the box method, FOIL method. If you were to multiply these 2 expressions, students, you won't get a 2x squared, okay? But if you were to multiply these 2 expressions, x times 2x, that gives me a 2x squared. And then you just keep multiplying using the FOIL method or the box method or the rainbow method, okay? So please trust me when I tell you, if you don't divide at least one expression out, your answer is probably wrong. Okay. All right, let's go ahead and move right along to B. We're going to do the exact same thing. Again, we're going to ask ourselves, can we factor out the GCF? Is there a GCF? No. We have a 3, 7, and 6. We can factor out a 3 between these 2 numbers, but it has to be all 3. So we cannot. So we're going to revert back to what we learned in example 2A. We're going to create the big X. Remember, I'm going to take my highlighter and highlight this 3. That's going to remind me, hey, bring that down. You can already start creating your binomial expressions. So we know we're going to bring down that 3x. Okay. All right, so multiply A times C, which is 3 times a negative 6. That gives me negative 18. Our B value is a negative 7. And I'm thinking of 2 numbers. Let's see. Negative 18, negative 7. 1 has to be negative, so negative 9 and 2. Let's check our answers. Negative 9 and 2. A negative 9 times 2 is negative 18. Negative 9 plus 2 gives me a negative 7. So minus 9 and plus 2. Again, it doesn't matter which one you decide to put first. You can put plus 2 and minus 9. Remember, you are going to have to divide an expression out. And it looks like we're going to divide the first expression again. Looks like we can divide a negative 3 out, sorry. So our final answer is going to be x minus 3, and then 3x plus 2. Again, we're practicing factoring. Students, if you are so confused and you have no idea, why don't you go on YouTube? You guys are good at looking stuff up. Go on YouTube, type in factoring where a is greater than 1, factoring trinomials where a is greater than 1, and they'll give you a bunch of videos. They are probably going to show you several different ways, but I'm sure you can find a video using the big X or the X factor. All right, we have 2 more. For example, 2. Let's keep going. Again, can we factor out a GCF? We have 4, 13, and 3. Nope, doesn't look like we can. So let's go ahead and create our big X. Because a is greater than 1, we are going to bring down that 4. So let's go ahead and do that now. 4x and 4x. Okay. And let's go ahead and multiply a times c, which is 4 times 3. That gives me 12. Your b value is going to go here. Anytime you see this, you're probably going to have to use this number 1 in the number. So, of course, it's going to be 12 and 1 or 1 and 12. Okay. So we're going to put plus 1 and plus 12. All right, we're looking at our expression. Because this is greater than 1, we know we're either going to have to divide out both or 1. Looks like it's going to be the second expression. We're going to divide a 4 out. And we're going to have 4x plus 1 and x plus 3. That's your final answer. Again, you can always check my work, check your work by using the FOIL method, box method, or rainbow method. Okay. All right. Let's take a look at D. Anytime you have a negative here, students, you probably can factor out a negative 1, which I suggest you do. As your leading coefficient. Okay, so we do have a negative here. Before I even start, let me go ahead and factor out that negative 1. That's going to make this 4x squared plus 8x minus 5. Okay, now I'm going to do 2 things. I am going to highlight this 4 and then highlight this just whatever's inside the parentheses, because that's telling me I'm going to use the big X, and I'm going to bring down this 4 and create my binomial expressions. 4 times a negative 5 gives me a negative 20. And our b value is 8. 2 numbers that come into mind are 10 and negative 2. So plus 10, oh, I'm so sorry, I forgot to bring down that negative 1, and minus 2. All right, students, remember I said if you can factor out both, please do so. If you can factor out a number, divide a number out, and we actually can. It looks like we can divide 2 here, a 2 here, and a 2 here. Okay, let's simplify. So we have our negative 1. We have 2x plus 5, and then we have 2x minus 1. And there's your final answer. Okay, so we're going to put a star next to this one, because this one we were actually able to factor out a 2. Notice how it wasn't a 4. It's not always going to be the coefficient here, okay, where it was before. All right, there's your answer. Let's go ahead and move right along. We're almost done, students. Of course, you know, we've been factoring out the GCF. Factoring a is greater than 1 when there's no GCF. Now, I think we're confident and we're comfortable. We're going to do 2 problems out of your textbook. This This is, our focus is going to be actually solving now. So remember back in 2.5, I said, make sure it's set equal to 0. If it's not, we need to move some numbers or an expression over. And then once we set it equal to 0, we need to look at a couple of things. Okay, a couple of things we need to look at. Is there a GCF we can factor out? We have a 2, -5, and -18. I was going to try to factor out a 2, but we can't because 2 doesn't go into -5. So let's go ahead and use that big X. We are solving, so we're going to set it equal to 0, which means we might end up having some fractions here, students, and that's okay. Fractions are our friend. All right. A times C, so 2 times a -18 is -36. And our B value is -5. Again, students, you were to stop the video, go ahead and write out the outline of this, and then let's get started. Okay, so our two numbers are going to be -36 and -5. I know 4 times 9 is 36, and we can get a difference of 5. So one of them has to be negative. Let's see. If I add a negative here, multiply, I get that, but I get a +5. What happens if I add the negative here? Yep, this works out. 4 times -9 is -36. 4 plus a -9 is -5. So we have 4 plus 4, and we have a -9. Again, we're setting it equal to 0 because our goal is to solve. So we can actually simplify. We can divide this by 2, and you end up with x plus 2, and 2x minus 9 is equal to 0. Okay, we are solving here, so let's keep writing. We're going to set this equal to 0. And we're going to set this one, 2x minus 9 is equal to 0. Okay. Final answer, we know subtract 2, so we get a -2. Here we're going to have to show a little bit more work. Plus 9. You end up with 2x equals 9. Divide by 2, yes, we end up with a fraction. 9/2 or 2.5. So your final answer x is equal to -2, and x is equal to 9/2 or 4.5. Okay, doesn't matter, I'll have both answers. All right, let's go ahead and do number 28, or also known as B in our textbook. Okay. First thing we want to do is make sure it's set equal to 0. It is not. Okay, this is our B value, so we're going to move that over and we're going to rewrite this. I'm going to add 3b. And I'm kind of going to just put it over here in the corner, floating around on the side, because I'm not adding it to any of those. So I'm going to rewrite this. This is going to be 14x squared plus... Oh, that's weird. I have a... I have 2 letters. Okay, I'm not sure out of the textbook what I did. Okay, we'll just call this x. Okay, 3x, and then -2 is equal to 0. Okay, so I had 2 variables, and I don't know where my whiteout went. So this is a 3x. I'm adding 3x to both sides. All right, GCF. Is there a greatest common number factor that I can divide out? No. All right, so I'm going to take this 14, highlight it, and I'm also going to use the big X. Before I start doing anything, let me go ahead and write this 14x. Oh, geez. I don't have my highlighter. I mean, my highlighter. Okay, Mrs. Holmes, calm down. 14x. Okay. 14 times the -2 gives me -28. That goes on top. And 3x is, or 3 is on bottom. What 2 numbers make up 28? I'm coming to mind is 7 and 4, but it has to give me a +3, so it's going to be 7 and -4. So +7 and -4. Okay, and it looks like I can actually divide a 7 out here, and I'm thinking 2. Yeah, 2. Okay, so that gives me 2x plus 1 and 7x minus 2 equals 0. Okay, so that will help me create my two equations. 2x plus 1 is equal to 0, and 7x minus 2 equals 0. Just by looking at the numbers, it looks like we're going to have two fractions, okay? So please do not be scared about fractions. 2x is equal to negative 1. That means x is going to equal negative 1/2. Okay, there's one answer. Add 2. So all I'm doing is just solving one two-step equation. 7x is equal to 2. That means x is going to equal 2/7. All right, there are my two answers, students.